All right, guys, we're going to take a look at our next topic, which is multiplying radicals. I think a lot of you are going to like or think it might be easier than the adding and subtracting. At the top of the notes, you have the 3 steps to do these. So your first step is you're going to multiply or distribute the coefficient. Step 2, you're going to multiply or distribute the radical. And then step 3, you're going to simplify the lowest term. So we still might have to do like the simplifying that we did in the first day's notes. So if you need to refer back to those videos, if you forgot how to do that. All right, so what I did is I broke up your notes into like 3 sections. So we're going to look at the first section, which is a monomial times a monomial. It's just kind of the easier stuff. So if I look at this first example, there's an imaginary multiplication sign in between there. So if I multiply them, the coefficients are both, there's an imaginary 1 in the front. 1 times 1 is 1. I'm going to multiply underneath the radical, so I get the square root of 48. Okay. Now, then you always need to ask yourself, is that completely simplified? So the square root of 48, I know I can break up into perfect square of 16 times 3. So my final answer would be 4 radical 3. All right, so this next one, you're going to, step 1 is you're going to multiply the coefficients. So I have an 8, 4 times 2 is 8, and then you're going to multiply your radicals. So radical 3 times radical 7 is radical 21. Now ask yourself, can you simplify your radical to lowest terms? In this case, you can't. So your final answer would be 8 radical 21. All right, so if we look at the next one, very similar to when we just did. Multiply the numbers in the front, then multiply your radicals. So this gets me radical 20. Now I know that I can simplify radical 20. So I can split this up into radical 4 and radical 5. And then if I go through and I simplify, so my final answer would be 20 radical 5. Okay, those are the easier ones. As you can see, they're pretty straightforward. Now the next section is a monomial times a binomial. This looks very, very similar to what we've done if I gave you something like this. If I asked you to simplify that, you would simply distribute. That's exactly what we're going to do here. We're going to distribute the radical or the coefficient on the outside. So when I distribute that inside, if I multiply those, I get radical 12, radical 2 times a positive radical 7. Well, that gets me radical 14. And again, ask yourself, can you simplify these? So I know this one I can break up into 4 and 3. And radical 14, actually you can't break down. So my final answer would be 2 radical 3 plus radical 14. Now remember, you cannot add those radicals because they're unlike. So for the next one, if I look through, I have an imaginary 1 in the front. So 1 times 2 gets me 2. Radical 3 times radical 6 gets me radical 18. And then if I distribute the next one, this gets me 1 times so it's going to be negative 1. Because again, there's an imaginary negative 1 there. So don't forget that. Times radical 3 times radical 3 gets me radical 9. Go ahead and simplify. So 2 radical 9 and 2 minus, I know what the square root of 9 is, and that's 3. Okay, so 2 times 3, radical 2 minus 3. So my final answer will be 6 radical 2 minus 3. Go ahead and pause the video. Why don't you give this one here a try. So again, I'm going to distribute through. So if I distribute through, I get 6 radical 20. So 2 times 3 gets me 6. 2 times 10 gets me 20. 2 times 2 gets me 4. 2 and 8 gets me radical 16. Again, break down those radicals. So I can break this up into 4 and 5. Now the square root of 16 is actually a perfect square, so I'm going to bring down that 4. I'm going to simplify the square root of 16. So I get 6 times 2, radical 5, plus 4 times 4 is 16. So I get 12, radical 5, plus 16. And that is my final answer. Okay? So these are more like your distributive property for this one. Okay. All right, last section. Monomial times a binomial. So these are going to be the ones that look like these kind of examples. Okay. So in the past, you would do your double distributive property. You'd simplify. Same thing we're going to do here. So you're going to take the numbers in the front and multiply them. Then you take that first number and you're going to multiply it to the back. So 2 times a negative radical 3, that's a negative 2 radical 3. And then you're going to take that second number, just like here, I distribute it to both numbers. I'm going to do the same thing here. So I get plus 2 radical 3 minus radical 9. So go ahead and check. I know negative 2 radical 3 plus 2 radical 3, those are considered like terms because they have the same radical. They actually cancel out. So I'm left with 4 minus, well, the radical 9 is 3. My final answer would be 1 for that. All right, so this one, everyone always forgets this example. This means that you have 3 plus radical 5 times 3 plus radical 5. So it actually is being disguised as this example over here. So you're going to go through and do the same thing. So 3 times 3 gets me 9. 3 times radical 5 is 3 radical 5. Radical 5 times 3, 3 radical 5. Radical 5 times radical 5 is radical 25. Here are my like terms in this case. So positive 3 plus a positive 3 gets me 6 radical 5 plus 5. These are my like terms. So I have 14 plus 6 radical 5. So if you'd like, here are just some more examples. If you want to try these on your own, I'm going to quickly just run through the answers. So if you'd like, pause the video, give these 5 examples a try. All right, go ahead, check your answers. If you have any questions, again, email me. Let's set up a time this week to do a Google Hangout so that we can do a video chat if you're having trouble.